Okay, 7.5, solving linear trigonometric equations. Actually, we did similar questions in chapter 6 when we did trigonometry unit. But mostly with chapter 6 we worked with special angles. Now we're going to look at other types of angles too. Okay. So it says solve for x, and x is an angle between 0 and 2 pi. And we're going to find the angle and round it to 3 decimal places. So we are given sin x plus 1 over 4 equals 0. So first we are going to isolate the ratio sin x equals negative 1 over 4. And let's remember the steps. So first write the ratio for related acute angle. So we are going to get positive 1 over 4. Then we are going to get the acute angle itself. Okay. So we are going to do now, make sure your calculator is in radians mode. So we are going to do now sine inverse of 1 over 4. So sine inverse of 0.25 or 1 over 4. So that gives you 0.253. Okay, 0.253. So that is beta, but we are gonna get x. So we can sketch this. We are looking for where sine is negative, and sine is negative in quadrant 3 and in quadrant 4. So we have two angles. Okay, so using cast, we know that sine is negative in quadrant 3 and quadrant 4. So then angle x is, the one that is in quadrant 3 is going to be pi plus beta. So 3.14 plus beta. Pi plus 0.253, which is beta, gives you 3.395. 3.395. Okay, and the x, the angle that is in quadrant 4, is going to be 2 pi minus beta. 2 times pi minus beta 0.253 gives you 6.030. 6.030. Okay, let's look at the next one. Tangent x plus 9 equals 1. Again, first isolate the ratio. So 1 minus 9 gives you negative 8. Okay, then write the ratio for related acute angle. Tangent beta equals positive 8. Then use your calculator in radians mode and do tan inverse of 8. 1.446. So beta is 1.446. Then sketch the angles. Cast. So we are looking for where tangent is negative. Tangent is negative in quadrant 2 and quadrant 4. So one of them is going to be pi minus beta, and the other one is going to be 2 pi minus beta. Okay, so pi minus 1.446 gives you 1.696. 1.696. And the other one is going to be 2 times pi minus beta 1.446, 4.837. 4.837. Okay, so next question, again solving trig equations, linear trig equations, but this time it says find exact solutions, means the angles that you will get will be special angles. Okay, so again same idea, isolate the ratio, so you get 1 over root 3. Well, we can't work with the cotangent, right? You have to get the tangent. So tangent x, just flip the fraction, you will get root 3 over 1, which is root 3. Then of course write the ratio for related acute angle. It is still positive root 3. Then think of special angles, 30, 60, 45. Which one gives you root 3? Yeah, 60 degree or pi over 3. So since we are working with radians, so pi over 3. Then sketch the angles. So we are looking for where tangent is positive. Tangent is positive in quadrant 1 and quadrant 3. So one of them is x equals beta, and the other one is pi plus beta. Then one of them is pi over 3, and the other one is pi plus pi over 3, which is 4 pi over 3. Okay, next one. So we are going to isolate cos x. So move negative 1 to the right. Negative 2 plus 1 gives you negative 1. Divide both sides by root 2. You get negative 1 over root 2. So write the ratio for related acute. You get cos beta equals 1 over root 2. Now get the beta. So 1 over root 2. So 45 degree, or pi over 4. So beta is pi over 4. Then sketch the angles. So we are looking for where cosine is negative. So using cast, cosine is negative in quadrant 2 and quadrant 3. So x is pi minus beta, also pi plus beta. So pi minus pi over 4 gives you 3 pi over 4, and pi plus pi over 4 gives you 5 pi over 4. Okay, these ones are a little bit different. So on the first page we only had sine x or cos x or tangent x, but look at a 3a. Okay, so you are again solving for x. So we have sine x cos x equals root 3 over 4. We don't have sine x only, we don't have cos x only. So how are we going to solve this? Okay, so now, if we were able to write it as a single ratio, that would be great, right? So now when you look at these double angle formulas, actually one of them is very close to sine x cos x. So which one it is? Sine 2x formula. If actually this was 2 sine x cos x, then you would replace it by sine 2x. Okay, so it is sine x to cos x. So what we can do, we can actually multiply both sides by 2. So that gives us 2 sine x cos x equals root 3 over 2. Now I can replace 2 sine x cos x by sine 2x. Okay. So again we are going to write the ratio for related acute, which is root 3 over 2. Then we are going to get related acute angle itself. So sine of what angle gives you root 3 over 2? So that is pi over 3. Okay, then you are going to look at where sine 2x is positive. Okay, so sine is positive in quadrant 1 and quadrant 2. Okay, so you have two of these angles. Then the angles that you need is beta itself, okay, and pi minus pi over 3, 2 pi over 3. So 2 pi over 3. But are those x? Not really, right? Those are 2x. So those are 2x and 2x. Okay, then we can calculate x by dividing both of them by both sides by 2, right? Then we get x equals pi over 6, and this one gives you x equals pi over 3. But we are not done, and this is the reason. Because if you had sine x only, okay, so I'm just gonna draw one period for regular sine x, okay, and if you were looking for where sine x equals root 3 over 2, you would get two solutions, right? So one is here and the other one is here, and those two solutions we already calculated, pi over 3 and 2 pi over 3. So those two answers you would get if it was sine x equals root 3 over 2. But now we are looking for where sine 2x equals root 3 over 2. Okay, so there's gonna be difference, right? And if actually if you sketch sine 2x, what is the period? Period is 2 pi over k, and k is 2 in this case. Okay, and the period of sine 2x is pi. So if this is pi, so I need to fit one cycle in that period. And then if you have 2 pi, of course, you know, you have the second cycle. So pi, 2 pi. So that would be the sketch of sine 2x, quick sketch. Okay, so now our question is where sine 2x equals root 3 over 2. So root 3 over 2. Now in 2 pi, okay, because the x must be between 0 and 2 pi. So how many solutions you get? 1, 2, 3, and then 4. Actually you should have 4 solutions. So when we got x here, pi over 6 and pi over 3, so these are the first two solutions. But actually I need to get other two solutions. So how can I do that? So as you see, between this point and that point there is one period, okay, and between this point and that point there is one period. So I can add one period to pi over 6 to get this point. So period, we said it is pi, right? So pi over 6 plus pi gives you 7 pi over 6. Pi plus pi over 3 gives you 4 pi over 3. So those are the next two solutions. So not only pi over 6 and pi over 3. Okay, so we also add one period to it, which is pi, and get 7 pi over 6. And we add pi to pi over 3 and get 4 pi over 3. So how would you know how many times do you need to add period to get more solutions? Okay, so you can keep adding the period. When you are over 2 pi, then you stop. Okay, you should not be taking those solutions. Let's say you didn't know where to stop and you wanted to add one more pi to this. Okay, one more period to this. What do you get? 7 pi over 6 plus pi gives you 13 pi over 6, which is over 2 pi. Okay, so it means that you cannot have that solution. Your solutions must be between 0 and 2 pi. Then, you know, even if you try to add one more period to these solutions, then, you know, it's not going to be useful because it's not going to be in the given domain. Okay, so we have then 4 solutions here. Okay, cosine 3x equals negative root 3 over 2. Looks like we will be answering this question similarly. So first, again, we are going to write the ratio for related acute. So that is positive root 3 over 2. Then we are going to get beta, which is going to be pi over 6. Okay, so we are looking for where cosine is negative. Okay, so using cast, cosine is negative in the second quadrant and in the third quadrant. Then those two angles are going to be pi minus beta. So one of them is going to be 5 pi over 6 and the other one is going to be pi plus beta, so 7 pi over 6. But these are not x. Those are going to be 3x. 3x. Okay. Then we can divide both sides by 3. So x is 5 pi over 18. Let's do it here. So x is 5 pi over 18 and 7 pi over 18. Okay, so but the period is different again. If you had y equals cos x, okay, so you would start from maximum, 0, minimum, 0 and maximum. So again, I'm just drawing one period between 0 and 2 pi because that is what is given to us, right? If you were looking for where cosine x equals negative root 3 over 2, so negative root 3 over 2, and you would have, as you see, two solutions, right? And we already know what those two solutions are, 5 pi over 6 and 7 pi over 6. But now we have cosine 3x. So cosine 3x period is 2 pi over 3. Right, so you will have 3 cycles in 2 pi. So 3 cycles. So something like this, okay. So you will have 1, 2, 3 cycles in 2 pi. Now, so that is 1, that is negative 1. If you are looking for negative root 3 over 2, okay, so where cosine 3x equals negative root 3 over 2, then how many solutions you get? So 1 here, right? 2, 3, 4, 5, and 6 solutions. Okay, so far we got first two, 5 pi over 18 and 7 pi over 18. So we need to get others. Okay, but again, between these 2 points there is 1 period. These 2 points there is 1 period, and same thing here, between these 2 points 1 period, and again there is not there but here. Okay, so you have 1 period. So we are going to keep adding periods to these 2 solutions to get other solutions. Okay, so we said that period is 2 pi over 3. So now I'm going to add two pi over 3 to this, and same thing, 7 pi over 18 plus a period 2 pi over 3. So 6, 12, 17. So 17 pi over 18. And this one, 6, 12, 19. So 19 pi over 18. Okay. And we are gonna keep adding. So we are gonna add one more. So 17 pi over 18 plus 2 pi over 3. Have a common denominator. 12 plus 17, 29. 29 pi over 18. And this one, 19 pi over 18 plus 2 pi over 3. 12, so 21, 31. 31 pi over 18 you get. So you have so far 1, 2, 3, 4, 5, and 6 solutions. Okay, so let's say you didn't know again where to stop, and then you continued. If you add one more pi, let's do it here, 29 pi over 18. Okay, if you add one more period, 2 pi over 3 here, so you have 29 pi over 18 plus 12 pi over 18, 41 pi over 18. But as you see, this is over 2 pi, right? 2 pi would be 36 pi over 18. This is 41 pi over 18. So you get a solution that is over 2 pi. So that's not acceptable. So then, you know, those are the 6 solutions that we're going to have. So next one. Okay, so first step, write the ratio for related acute angle. Get related acute angle, which is pi over 6. Okay, so this side, now do the cast. Okay, so we are looking for where sine is positive. So sine is positive in quadrant 1 and quadrant 2. So then you have two angles. So one of them is equal to the beta, and the other one is equal to pi minus beta, 5 pi over 6. But these are not x, but x over 2. X over 2. Okay, so now you can get multiply both sides by 2, you get pi over 3 and 5 pi over 3, and check your final solutions if it is in the given domain. So again, domain is x is between 0 and 2 pi. Okay, do you need to add the period here? Well, the period here is what? 2 pi over 1 over 2, right? 2 pi over 1 over 2 gives you 4 pi. If you add 4 pi to these two solutions, right? Actually, you are getting solutions that are over 2 pi. So you have two solutions here. If we sketch it here, okay, again, if you have sine x and if you are looking for where sine x is equal to 1 over 2, so you get two solutions, right? Two solutions which are pi over 6 and 5 pi over 6. So that is for sine x. If you have sine 1 over 2x, the period is 4 pi. Okay, so if you are looking for where sine 1 over 2x equals 1 over 2, you still have here two solutions. Okay, then we said that these are pi over 3 and 5 pi over 3. Okay, sine 1 over 2x equals negative 1 over, no, positive 1 over 2. But let me tell you one more thing here. How about if the question was sine 1 over 2x equals negative 1 over 2? Let's say this was the question. Okay, then if it was sine x, you would have two solutions here, right? If it was negative 1 over 2, so you would have this solution and that solution. But for sine 1 over 2x, solutions would be here and here. But look at those two solutions. They are greater than 2 pi. Then you would say no solution. Okay, based on the given interval. So then you would say no solution here.